We are going to do exercise 1-4 from chapter 1 of the book. We need to find the graphical solution of this LP problem. In order to do that, we need to sketch the feasible region in order to find the corner that the optimal solution occurs. So we're going to graph 2x1 plus x2 equals 70, x1 plus x2 equals 40, and x1 plus 3x2 equals 90. So for the first one, when x1 is 0, x2 is 70, and when x2 is 0, x1 is 35. So we're going to have the straight line from 70 down to 35, and this is 2x1 plus x2 equals 70. It's good to know which one is which. So now for the second one, when x1 is 0, x2 is 40, and when x2 is 0, x1 is 40. So we're going to have the straight line from 40 down to 40, and this will be x1 plus x2 equals 40. And now the last one, when x1 is 0, x2 is 30, and when x2 is 0, x1 is 90. So we have the straight line from 30 to 90, and this is x1 plus 3x2 equals 90. So from our constraints, we get that the feasible region is the area that it is greater than or equal to each of these lines. And also we have to keep in mind that x1 and x2 need to be greater than or equal to 0. So the area that the three constraints coincide is this region. This is our feasible region. Now we are going to draw some level sets of Z. We are going to choose Z equals 0, Z equals 2,400, and Z equals 3,600. We have to keep in mind that Z is equal to 40x1 plus 60x2. So for Z equals 2,400, x1 would be 60 over here, and x2 would be 40 over here. So we are going to have the straight line from 40 down to 60, and this is when Z equals 2,400. Now for our next level set, when Z is 3,600, x1 is 90, and x2 is 60. So we have the straight line from 60 down to 90 as our next level set. And this is when Z is equal to 3,600. And lastly, we have Z equals 0, which is the line that goes through 0, but it also needs to be parallel to the other level sets. So this is when Z equals 0. We can see now that the level sets never leave the feasible region. Since a feasible region isn't bounded, they keep increasing and they stay inside the feasible region. So in this case, we say that we have arbitrarily large solutions. And this is it.